Hello and welcome to Sean White's Solar and Energy Storage Podcast.
In this podcast, we're going to talk about the 2020 National Electrical Code, Article 706, Energy Storage Systems, with Bill Brooks. Bill Brooks is the guy who wrote a lot of this material in Article 706 and was there every step of the way. Sometimes Bill does not agree with what ends up in the NEC, and he will let you know it here first on this podcast. Sit back, drive down the road, or do whatever you're going to do while you're listening and enjoy.
To have fun and learn more about solar and storage, go to Solar, S-E-A-N, that's SolarSean.com.
On with the show.
Let's talk about Article 706. And yeah, we're coming at you with energy storage systems. That's Article 706 from the headquarters of Brooks Engineering with Bill Brooks. We're hanging out. We're talking about the NEC. What could be better? Yeah, we got the life.
So we're now in the 2020 NEC. Before it said it didn't cover systems over under 50 volts AC or 60 volts DC, which was a little bit strange and silly, and that got fixed in the 2020 code. And it goes along with that same number we saw in the residential code of 1 kilowatt hour. Electrical code and the residential code do not apply to less than 1 kilowatt hour battery systems. And that certainly would include a lot of things like backup UPSs for your computer and stuff like that would not be covered under this. And of course, those are listed devices anyway. This is my favorite informational note in the entire National Electrical Code. We have to talk about it. This is the biggest bullshit on the planet. There can be a subtle distinction between the battery storing energy and an energy storage system. This is just the most ridiculous thing to say that there's a subtle distinction. Now, there has been a distinction created in the 2023 code to help with this idea, but to say that there is any distinction provided in the 2020 code about the difference between a storage battery and an energy storage system is absolutely ludicrous. And a storage battery, the intention behind Article 480 from 100 years ago, literally, when storage batteries were part of the world, was that it was for things like a storage battery used in a substation to provide power in a power outage, independent from everything else, to operate the controls and things like that in a substation. Okay, so they call them a substation battery. That is a storage battery. And if that were under any requirements in the NEC, you would use Article 480 for that. It's a battery that just sits there all the time. It's like a UPS. A UPS is slightly different than a storage battery because it includes things like inverters and stuff like that. The storage battery would just be chemical battery portion of that UPS. So there are UPSs that include a large storage battery with an inverter. And in the future, where things are going is that a storage battery is going to be relegated to things like lead acid that are just designed to stay there at float most of the time and only in power outages ever be used. An energy storage system is being the distinction, which is a not so subtle distinction, is to separate these two things and say that if you're using the battery for the purpose of daily operations, where you're dispatching the battery and charging the battery on a regular basis, then it is not a stationary storage battery as Article 480 always talked about in the past. It is a very unique new thing that's only been out there for a little while, which is this concept of using a chemical battery in a day-to-day operation for building electricity. That's kind of where it all comes in. We use batteries for forklifts, right? We use batteries now for electric vehicles. Those are very different applications and they are not ESS. And so those are vehicle batteries.
I guess like the older NEC also applied to the whole electrical transmission system. And now we have the NESC.
So way back when, the Article 480 has been used historically just for that application. And about 25 years ago, we started using, or maybe more like 40 or 50 years ago, we started doing off-grid homes where we had a storage battery that would actually be used to power a home. And Article 480, we'd use it, but it was almost worthless in its value. I mean, there was nothing in it. It just said that batteries needed to be ventilated, but not all batteries needed to be ventilated.
Yeah, the 480 part, I was trashing 480. That's the part we skipped. For
and that's good. So we're in 706. We're going to focus on 706, but that's a silly informational note.
Yep.
And then this is a bunch of standards. And a couple of the standards that are important to us are highlighted 1973, which is the batteries that the valuation they go through before they go to 9540. So you need a 1973 certification before you go to 9540. And 1973 actually calls up 1989 for lead acid batteries. And so lead acid batteries will go through a 1989, which will be actually covered under 1973. So at the end of the day, all of our batteries, the actual chemical battery itself is going to be covered by UL 1973. And then when we put it into an energy storage system, it'll get covered by 9540. So 9540A is somewhat confusing because it's a test method, not a standard. It's intended to be a large-scale fire test for products that are working their way through UL 9540. It is not required of every product that goes through UL 9540, but it will become a very common test method, and linking it to 9540 is not the worst thing in the world, other than some people might think, well, which test standard do I use? And the answer is, well, no. 9540A is a large-scale fire test. 9540 is the overall safety certification.
This test sounds kind of fun. You make sure the BMS doesn't work and then you blow it up.
Pretty much. Catch
fun.
it on fire and see what happens. So, energy storage system, this is just definitions. And that's providing electrical energy into premises wiring system or electric power production and distribution network, which would include the utility. So it either is feeding power into a house, building, or the utility. And this is just more information about definitions in the informational notes. They can include inverters and things like that, and most of them actually do. Now, the informational note 2 says that they differ from a UPS system. And so that's because the UPS people don't like to be lumped into that. And a UPS is a different animal. And that is something that operates at float most of the time, and then in a power outage provides power. Well, guess what? We do that with our systems too.
Yeah, there's a lot of crossover.
Okay, so let's just take a look at this. So when you're doing a UPS, you're going to be looking at Article 702 optional standby systems. And there's a reason that you want to avoid that article when you're doing a solar and energy storage installation. And let's look at this, the reason why. 702.4B2A, full load. The standby source shall be capable of supplying the full load that is transferred by the automatic transfer equipment. So if you call it an automatic transfer switch, you will have to back up the full load. However, if you call it a microgrid interconnection device, and that's a device that enables a microgrid system to separate from and reconnect to operate in parallel with a primary power source. So it kind of is an automatic transfer switch by another name, but it's called a microgrid interconnect device, MID. Then if we look at Article 710, standalone systems, 710.15a, it says over here that standalone supply shall be equal to or greater than the load posed by the largest single utilization equipment connected to the system. So what this means is that all you have to do is to be able to power the largest load, and that would be the sum of all sources too. So that could actually mean that you have full sun, full battery, and full generator. So you can have a rather large load that would be even more than the output of your inverter if you had other sources such as a generator, etc. So you got that? Call it a microgrid interconnect device. Don't call it an automatic transfer switch. Now let's go with the flow and back to Bill.
Again, a lot of this information for flow batteries, you could say that they're similar to fuel cells. It's not the greatest analogy in the world, but it's a helpful one to think about, and you can read up on flow batteries. They are certainly being used currently in some large-scale facilities. The companies that make flow batteries would like to use them in residential. I think they're out of their minds because they just take up too much room.
Zinc bromine and vanadium redox is
two most common, but there's some other ones coming out as well, and we'll see how they all do. Inverter utilization output circuit. What the heck? I mean, it's the inverter output circuit. So we're in the 2020 code, right? It's just saying that there has to be a nameplate visible after installation with all of this. Okay, so part of the 9540 process would be to put this on that label. Manufacturer's name, frequency, phases, rating, available fault current derived by the ESS at the output terminals. That's weird, okay? If the output terminals of the ESS are AC, which they are in many cases, the available fault current is almost zero. I mean, it's the same as the rating of the... Originally, they wanted that in there because they were worried about the DC output current being very high for batteries, which it is if it's not going through electronics. But most all ESS at this point go through electronics. So their available fault currents are almost
So you just
no
put
different.
the output current as a fault current.
We should do away with the fault current because it's
Do away with it.
insignificant. But there it is. And they'll have that on there. And to do it right would mean that the output current and the fault current are almost the same number.
Or I guess maybe the fault current would be more like the surge current.
Yeah, maybe. It's a completely wrong concept for this equipment.
Yeah.
And then if it's utility interactive capable. So current, voltage, and interactive capability. So this is just more explanation about that.
So isn't it strange that your energy storage system on the label has to have the power, but not the energy? So why don't they call it a power storage system? Well, you can't store power, but you sure can put it out.
Now, there's a lot of the definitions have gone into the Article 100 section in the 2000 code. In the 2023 code, 100% of the definitions will be in Article 100.
Yeah. Talks about stuff being listed, so that's just UL.
Yeah.
Listed. Energy storage be listed 9540 1973. We had an informational note, but now here is stating it in the code, not just an informational note. And then I was just looking up some different batteries. So we had LG Chem 1973. You were talking about that earlier. LG Chem with BYD and SMA as a group 9540.
Solar Edge would be another example.
Powerwall 2, both of these. You were telling me earlier that this is the umbrella standard, 9540, and underneath the umbrella is 1973.
Correct. So 1973 is always going to be part of 9540. So if we talk about 1973, there's nothing wrong with that. And so we could have something that was just 1973. And according to Article 706, it might be acceptable in the code, in the National Electrical Code. What it will not be acceptable for is the residential code, because the residential code clearly calls out 9540. So it would not be sufficient, and they'd have to go the next step to 9540. There's your double stacks.
Installed in or on. Multiple shall be permitted. Multiple systems. So there anything wrong with that installation? There's some windows there, huh?
In the new residential code, if those windows are not going into a garage, if they're going into the living space, then that would be a little bit too close.
And that looks a little nice for a garage window, huh?
Looks kind of nice, but so that's a possibility. That's a big battery right there.
Yeah.
100 kilowatt hours.
And so these are okay? Is there any rules about that?
We're caring about fire going into the house. We're right on the edge of that 3-foot number there. And the way to get away from that, you'd have to take essentially an arc and draw it around from the edge of the window down. And so you'd have to probably space that one that's underneath, that triple stack that's underneath the building. Oh, that's 120 something kilowatt hour battery.
Yeah.
Because it's got 2 triple stacks and 2 double stacks.
It's got 10 of them, yeah.
This is a rich guy. And so they would have to move. But that's a residential code requirement that's going to come into California this summer, in the summer of 2021, and is not currently required.
And so we could call each one of these as a battery and an inverter. Would that be
Yeah.
10 separate energy storage systems?
Yeah, that's 10 energy
So,
storage
and
units.
there's not going to be any kind of rule that we have too many kilowatt hours there.
Well, in the new rule, this would be over the top because it said 80 kilowatt hours on the exterior. So this is 120 kilowatt hours on the exterior.
But as long as you put it in before that new rule,
That's right.
so they shall be maintained. So there's a little maintenance in the NEC here.
Well, it's completely out of place. It's wasting paper in the code. So if it doesn't comply with ESS 706, then it shall comply with 480. So basically, this is your get out of jail free card. If you don't like what you read in Article 706, you just go to 480. That's the way the code is written right now. And it's impossible. We cannot move forward. I think they finally got the message this code cycle that the way they did it was wrong, and that 706 has to be for all energy storage systems that are providing power to loads in buildings for anything other than a standby operation.
And pretty much in 690, it tells you to go to 706.
It does. The intention was that 480 was going to go away in the first place, but never did. The maximum voltage is going to be whatever it is on the nameplate. If it's an AC system, it's an AC voltage. Disconnecting means, so this is kind of a problematic one. We're going to get into things like what are the requirements for the disconnect, and we have the Article 100 basic definition, which is disconnecting from the source. So it shall be provided, disconnecting means for all ungrounded conductors, can be integral with the ESS, and it has to comply with the following. Readily accessible, that could be a problem. In sight of the ESS, well, if it's in another room, that's impractical, but close as possible. Shall be lockable in the open position, and that's for maintenance and working on the equipment. And then for 1 and 2 family dwellings, they want this disconnect to be on the outside of the building.
So are they saying that just like somebody installs an energy storage system and you need to have like a disconnect that you can lock in the open position?
On the outside of the building, there has to be a disconnecting means or a remote disconnect. So it could be a remote actuator that's located on the outside of the building that actuates the disconnect inside the building. That's the requirement for 1 and 2 family dwelling. The challenge is, how do you do this in a way that where you're not running wires all over the place to accommodate this disconnecting means, which are going to be worse and more hazardous than just leaving them where they were. This is a bit of a problem. There's going to be new language in the 2023 code to help with this. The remote activation is a good start in the right direction, but it's not clear enough. So this is remote activation, where controls to activate the disconnecting means are used and not located within inside of the system. It should be field marked on the disconnecting means. So this would be in the Northeast, where most of your disconnects are going to be in the basement. It could be on the outside of the house and could be a remote actuator. But unfortunately, the disconnect that they specify here, it would not allow you just to turn the ESS off, and that's what's deficient about it. It would have to be an actual switch that disconnects the ungrounded conductor. And so what the firefighters want is not that. What they want is something essentially like rapid shutdown. That's what they're asking for. What they got was something different. They got a rotary switch or some kind of motorized switch activated remotely. And that's not what they needed, and that's not what they necessarily wanted. In the next code cycle, it'll be clear, we could have a switch. In fact, you could even use your phone to turn off an ESS, and it would be a safe way to do that. So if you had, let's say, a push button or something like that, like a rapid shutdown switch, you could rig that rapid shutdown switch to not only perform the rapid shutdown for the array and for hazard control in the array, but it also could send the signal to the ESS to turn the ESS off at the same time. And that would be an easy thing to do, and it would be one disconnect for all of those functions.
So could we have something that's wireless?
Absolutely. You would have to have a wireless protocol that was operating all the time that essentially, because you have to make these things fail safe. So the idea is that if you're using communications, the communications essentially have to operate off of keep alive signal. And then when the keep alive signal goes away, then it goes into safe mode. And that's challenging with wireless. It's more likely you'd probably run a control circuit, like a thermostat wire. But as you point out, it could be anything like that.
You like scan a QR code on the side of the house? Or?
It needs to be something that requires interaction to restart it. Because what you don't want is something to automatically, somehow somebody bumps against something and it all of a sudden restarts. Yeah. You want it to be turned off, everybody knows it's off, and then they turn it on purposefully.
There's not really a good solution to this right now.
To be compliant, the two options that are in the code right now are to run the wires like you just said, or to have a remote controller. But that remote controller is going to actuate something that's a physical motion. There are switches out there, there are motorized switches.
So have you seen any good solutions to this?
There are some motorized switches out there that are not super expensive, but they're expensive. You know, Midnight Solar makes one, and there are other companies out there that have them.
How about something coming up in the 2023 NEC? Is there going to be a change?
Absolutely. I mean, Enphase is already working on a product. Other people are working on products where you would just be literally a push button or some kind of... The actuator is very simple, and it's not having to open a circuit. It's just simply telling everybody to turn off.
So is it going to be this lockable thing and all that? You know, lock it in the open position? Or?
So it could be a push button that has a lock on it, or it could be even a knife blade switch with a lock on it. You know, but it's not actually operating the physical circuit. It's just operating a remote controller.
Like not a perfect solution?
Nope. So this is just to say plainly indicate off and on position. Again, a lot of this stuff comes from the Article 690, so they borrowed it and put it in 706. This is a good change in the 2020 code because the 2017 code was onerous on this one. Disconnecting means has to be legibly marked with the nominal AC voltage and DC voltage, and 1 and 2 family dwellings don't need to do the available fault current, the arc flash label, and the date the calculation was performed. Those are absurd. When we talk about ESS in general, all three of them are absurd anyway because most ESSs are going to have go through some type of electronics, so their available fault current and their arc flash capabilities are nil. Again, this was done by people that were talking about large, uncontrolled lithium-ion batteries before they ever got to any electronics. That's how they were conceiving all this stuff.
Which is not an ESS.
And that's not an ESS. Again, you got to put it in the right context. In the right context, this is silly.
So I was just thinking too about like that, where you have to have the disconnect outside. Pretty much you're just going to want to put the whole battery outside most of the time, just so you don't have to run wires from here to there and back.
It makes big batteries for sure. It makes sense. Again, remember, these disconnect requirements are just for 1 and 2 family dwelling, because there was an enormous pushback for anything else.
Oh yeah.
They're like, well, over my dead body, so to speak, are we going to be doing conductors to the outside of a building on a large system? That's just insane. There's a familiar label. If we have switches, which would be maybe on the DC side of a system that could be energized in both directions. Partitions between components. So if you pass through walls, then this came out of Article 690. Readily accessible disconnecting means shall be provided within sight of the energy storage systems. What it's saying is that if you have a switch on one side of the wall and then you go through the wall into another area, then the switch needs to be within sight of the energy storage component that we're talking about. So you could have multiple components in multiple rooms. Source disconnect. So this is connection to other sources. You have to have a means to shut off all sources. Of course, one source would be the ESS. The other source might be the utility PV system, something like that. If they're operating in parallel, they have to be listed as interactive. If interactive power is lost, then they have to follow the rules, which is part of the listing of the inverters. And for unbalanced interconnections, they're going to be covered by 705.45, which covers putting single-phase inverters on three-phase systems and things like that. Connection to other sources. This is just talking about references to other things. We're hopefully going to get rid of Article 712 DC microgrids, and it's all going to be incorporated into 705. We'll see how things come out on that. We actually looked at trying to get rid of 710 and incorporate it into 705, but it looks like we'll probably stick around with that at least one more code cycle on power systems.
Pretty short anyway.
It's pretty short anyway, so it's not a big deal. Ventilation, again, is only for stuff that produces gases under normal conditions, under normal charging conditions. You do not require ventilation for equipment that only produces gases during abnormal conditions. In fact, producing ventilation under abnormal conditions can be fire hazardous, and so it can cause explosions and stuff like that. So it's not necessarily a solution. Here's a fun one. ESS shall not exceed 100 volts between conductors during routine maintenance of live parts, unless during routine maintenance live parts are not accessible. Then we can go up to the maximum voltage that would be allowable in any place, and in a dwelling unit 600 volts DC seems to be fine.
Yeah, it's kind of funny, like what energy storage system is under 100 volts? I mean, it's not really common. You're going to be like even 120 volts plugging in your wall is...
Right. You know, the perception is this all came from Article 480 and Article 690, where the number was 60 volts, and that's where it came from. It came from 690 and said that if you're operating above 60 volts, like a lead-acid battery, if you've got a flooded lead-acid battery, then you'd have to protect it from live parts. Okay, this does not apply at all to lithium batteries, and because UL 9540 would never allow live parts to be available during maintenance anyway, this section of the code just doesn't apply. The confusing part is it looks like it kind of applies, and it doesn't.
Yeah.
And that's the problem with it.
I know it just starts off with shall not exceed 100 volts.
Yeah, and so everybody focuses on that, but once you read it, it never applies.
C1, 706.20C1, we're talking about spaces.
And that's Article 110.26, talks about spaces around electrical equipment, workspaces in 110.34. So just use those standard things. Those shouldn't be in the code because they're already in the code.
Yeah.
Space between components according to manufacturer's instructions. Again, we have to follow manufacturer's instructions for anything. Anytime we violate the manufacturer's instructions, not only do we put in peril the warranties, but we also create problems that we may not even know what the problems are. Nameplate rated circuit current. What's that? Well, that's whatever's on the nameplate rating. Puts out 30 amps, then we're going to size the conductors based on a continuous 30 amps. And this really, what it used to say in 690 is this points out that it talks about the lowest voltage at highest current And that's because batteries will reduce voltage as they go to a lower state in their chemistry. And when they do that, the inverter may actually compensate by increasing current. And because of that increased current could actually create a situation where if you didn't plan for that, you could overcurrent the wires. This was also in 690, and it basically says if you have a diversionary charge controller, those circuits can fail, and therefore you need a backup plan that may not be as good as that, but just basically protects you in case that fails. And then this is more detail about diversion loads and stuff like that, how big the loads have to be in order to comply, so that you don't overload.
So you kind of oversize your diversion load by another 50%.
Right. So you make sure you don't overheat your diversion load, because a lot of these are resistance heaters, and you can actually overheat them and stuff like that, cause them to fail.
Interactive inverter, if the grid is a diversion load, then you don't need to do that stuff.
Right. Charge controllers. And this basically says that if the current going out of the controller is bigger than the current going into the controller, you have to basically size your conductors according to whatever the current is. And so that's very true of DC to DC converters. They are the analog of AC transformers. And so we know that if we have an AC transformer where we put 480 in one side, we're going to have small wires going in the 480 side and big wires going out the 208 side. Same thing here. If we have 48 volts on one side of a charge controller, we might have 600 volts on the other side of the charge controller. Little wires on the 600 volt side, big wires on the 48 volt side. Low batteries, and where we use pumps to move electrolyte around, and that's pretty cool stuff, and that's in part 5 now. Kind of similar to fuel cells.
So you think we're going to start seeing more fuel cells? It's in the news and all that.
It's in the news. We'll see.
I just always, the round trip efficiency of a fuel cells just can't compete.
Yeah.
You're going to make hydrogen with electricity.
We like to consider fuel cells as a future technology that will always be a future technology. And this is all in the flow batteries, talking about the chemicals that are involved and signage related to that. And so this actually goes along with some of the things we saw in the fire code, where the fire code was telling you had to talk about the chemicals and the chemistry so that anybody doing emergency operations knew that what they were getting into. And so an acid mixture is common in these flow batteries, and it's not unlike lead acid batteries in the sulfuric acid combinations. And so, if you have a leak or something like that, that could be real problematic.
I've noticed, though, that some of these chemistries are not that toxic, like you can eat them.
Some of them, sure.
So we need to contain the spills of the electrolyte.
Yep, and that's for obvious reasons. If these things spill, they could be dumping acids onto other, a floor below them or something like that. So some method of containment needs to be there to be able to contain the rupture of any particular containment. It's the same thing with flooded lead acid batteries. It's the same concept. In a flooded lead acid battery, normally you size the containment for one cell losing its containment. And you may need more than that in some cases, but that's usually the minimum containment requirement.
Yeah, I mean, you definitely don't want a zinc spill, huh?
Spill of sunlight is just a nice day, right?
Yeah. Or a lithium spill, everybody will get rid of their bipolar.
That's right.
Systems.
All those bipolar people would be cured instantly. It's not how it works. Safety shutdowns for electrolyte block in the event of electrolyte blockage. Okay, so that's going to be an electric shutdown.
Kind of reminds me of solar thermal now. We're talking about like pumps and electrolytes.
More details maybe than should be in there in the electrical code.
When do we start bringing it to the plumbing code?
Exactly, because it is more plumbing than it is electricity. But the electrical side of it should be pretty straightforward, because we're just going to produce electrical energy, and therefore from that point on it's an electrical system and needs to follow electrical rules. And there's going to be listings on the electrical side and the inverters that are used and everything else. And then if we're connecting it into other equipment and we're interconnecting it, then Article 705 is going to apply.
Yeah, so it talks about like other energy storage technologies.
And this is the last part of Article 706, 706.50 General, and it pretty much says that the other types of energy storage technologies that we didn't cover pretty much follows the National Electrical Code. Sort of like before 1985 when they came up with Article 690 photovoltaic systems, you still used the National Electrical Code, but there wasn't anything specific for solar. In this case, for other energy storage technologies, which could be flywheels, which could be compressed air, which could be something that you're inventing in your basement right now that hopefully won't explode, you have to follow the National Electrical Code, and included in the National Electrical Code is Article 705. Follow the code, y'all. I always have people ask me about, can you make a pumped hydro for small scale, like just for your house? You know, have you ever heard of anybody
Absolutely
trying that?
could. Would it be practical and efficient? Absolutely not.
How efficient would a small hydroelectric turbine be? I mean,
How efficient?
yeah, can you get it to be 50%? I know the big ones get, what do they get? They can get up to like 90 or something.
I don't think they're anywhere near 90%. I mean, they may be 60 or 70% efficient, but that's still pretty respectable. You got to remember, you're talking about energy in to energy out. And so you got losses in pumps and pipes, all that kind of stuff. So your pump efficiencies are not even near that. The challenge is going to be in your turbines, your pumps and your turbines. So you have to have a really super efficient pump turbine.
And so you probably need $1 million one that's megawatts or something.
Yeah, I mean, typical micro hydro is using things like Pelton wheel turbines and stuff like that are fairly compact. And so they require a fair amount of pressure. So how high do you have to get in your house before you get enough pressure that you could actually drive a Pelton wheel? The answer is, could you actually convert electricity that way? And the answer is sure.
But
could you do it practically?
25% maybe?
Yeah.
Something like for a small
It's going to be
scale?
well below what you can get with a typical chemical battery at this stage in the game. So it's a cute thing to think about and talk about. It's completely impractical. Photovoltaics has essentially made solar thermal die. It's killed it. Because of the difficulty of doing pumps and everything like that in a solar thermal system. And solar thermal is far more efficient than photovoltaics. It's just the simplicity of photovoltaics wins every time. So much easier to produce, so much easier to install, so much easier to use. And when we couple with it heat pumps, which get us back a lot of the efficiency penalties of photovoltaics in a thermal process that is well defined and easy to do with products that are on the market, then essentially solar thermal, in my mind, as a mechanical engineer, is obsolete. And I believe that lithium ion is a good enough technology and is making lead acid better technology that these other ideas would relegate pumped storage to only the really massive nuclear kind of system level stuff, which is still very valid. Doesn't mean that it's not valid, but it takes up large land areas.
Not everybody has a reservoir.
Yeah, it's not simple, and it's got its hazards. You can't have people around this stuff. It has societal issues with it, albeit I think worthwhile. And it was invented for nuclear because nuclear was non-dispatchable. So everybody talks about the fact that solar's intermittent. Well, okay, great, but it works during the daytime. Nuclear is non-dispatchable, which means that it's always the same all the time, which sucks because you can't do anything with it at night.
Can't turn it off. Yeah.
Can't turn it off. You essentially have to do pump storage with nuclear, whereas other generation concepts are dispatchable, meaning you can ramp them up and ramp them down. Maybe not fast, but you can do it. And so most of the power plant designs using fossil fuels like combined cycle, which are very efficient, combined cycle plants using natural gas, can be ramped up and ramped down in a matter of tens of minutes to hours, whereas nuclear is days or months. As far as ramping times, they just don't ramp.
Have you seen these things where they're talking about lifting all these concrete blocks and making a tower, and they have a crane and it just stacks them all up and then it takes them apart for gravity storage? It's like been on the news and stuff like that.
Yeah, those ideas have been around since the dawn of time, literally. Yeah. It's not a new concept. It's been around forever, and it'll ultimately come down to cost and efficiency. And I can tell you that we did away with mechanical stuff a long time ago because it's not very efficient.
And then you hear people talking about flywheels too.
Yeah, and flywheels have their place for sure. You can get a lot of energy into a small amount of area, but they have their challenges too.
Yeah, the earth spinning kind of throws them off a little bit.
The bottom line in all this discussion about energy storage systems is we are going to have chemical batteries forever, period, end of discussion. Now, we may have other technologies that can help, but chemical batteries using chemical processes, chemical energy will be a part of the energy storage world forever. There will be nothing that will replace it. There will be some things that will take part of the market in certain areas. For energy storage for a house, the viable option is an electric vehicle in my mind. That's the viable option, but that's a chemical battery. This happens to be one that you can drive.
Yeah, and I guess like they look at some things maybe for long-term storage. So like if you were doing some gravity, long-term storage would work with that, or hydrogen.
Yeah, I mean, potential energy is potential energy. If we can make it, if we can put it at the top of a mountain and then only use it when we need it.
Did I ever tell you my idea about taking apart Mount Everest?
where you just take the top of Mount Everest off, bring it down to Bangladesh or wherever, where the sea level's rising. And then you just keep taking Mount Everest apart, and you'll probably have enough energy in there to last for centuries for the whole planet.
Hard to harness, though.
Then you have Everest Valley. Yeah.
Yeah.
You just put some rail cars up there, and electric trains in reverse, going down, some motors going in reverse, take it all apart.
Yeah, pretty tough environment to kind of work with, though.
No, I'll keep working on that.
Yeah. You can do that.
I think that's pretty good, huh?
Thanks for listening, and to learn more about the sun and everything else, go to solarsean.com.